Welcome students to the third module of chapter number 3, Current Electricity. In this module, we will be learning parallel combination of resistors. We will see the domestic electrical connection in detail and also will learn some precautions to be taken while using the electricity. Let us learn about the connection of resistors in parallel. Resistors are said to be connected in parallel when their ends are connected to the same two nodes, as you can see in the figure. Here the figure shows three resistors R1, R2 and R3 connected in parallel between point C and point D. Let V be the potential difference between point C and point D. And let I1, I2 and I3 be the currents flowing through R1, R2 and R3 respectively. Therefore, the total current will be I1 plus I2 plus I3. Let Rp be the effective resistance between point C and D. So, we have V equal to IR according to Ohm's law. Now here we have V is equal to IR according to Ohm's law. So we can write V is equal to IRP, where Rp is the effective resistance in parallel connection. So we get I is equal to V upon Rp, and I1 is equal to V upon R1. I2 is equal to V upon R2 and I3 is equal to V upon R3. Now let us put these values of I1, I2 and I3 in equation number 1. So we get V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. Now here V can be taken out as a common factor. So we get V upon Rp is equal to V into bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now, let us divide both the sides by V. So, we get 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If n number of resistors are connected in parallel, then we have 1 upon Rn is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 etc. up to 1 upon Rn. Here are some characteristics of resistors in parallel connection. We have learned that 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That is, the inverse of the effective resistance is equal to the sum of the inverses of individual resistances. The effective resistance of the resistors connected in parallel is always less than the least resistance of individual resistances. Therefore, this arrangement is used to reduce the resistance in a circuit. Next characteristic of resistors in parallel connection is the total current flowing through the circuit is the sum of the currents flowing through individual resistors. Therefore, I is equal to I1 plus I2 plus I3. The potential difference across all the resistors is same. Here you can see V is the potential difference between point A and B. Our households are full of electrical appliances such as an electric bulb, electric bell, electric fan, iron, electric heater, refrigerator, washing machine, etc. Do you know where does this electricity in our house come from? In our homes, either the overhead electric poles or underground cables support the power supply flowing through the main supply. One of these wires in this supply covered with the insulation in the color red or brown is the live wire, and another wire colored blue or black is the neutral wire. At the meter board, these wires pass into an electric meter through the main fuse. The main switch, live wire and the neutral wire are in connection to the line wires in our home. These wires then supply electricity to the separate electric circuits within the house. The third wire is called the earth wire and is of yellow or green color. Here in the picture, you can see a domestic electric circuit. In this circuit, the red color live wire and the black colored neutral wire, both these wires are connected to the electric meter through a fuse. Through a main switch, they are connected to all the conducting wires inside the home so as to provide electricity to every room. In each separate circuit, Various appliances are connected between live wire and the neutral wires. The different appliances are connected in parallel, and the potential difference across every appliance is the same. In India, the voltage difference between the live wire and the neutral wire is about 220 volt. Live wire is connected directly to the electric supply. It carries current towards the domestic appliances. Neutral wire emerges from the appliances and complete the circuit by carrying the current back to the power source to better control and regulate the voltage. Its overall purpose is to serve as a path to return the energy. Earth wire is helpful to conduct the excess or the leakage current from the electric appliances to the ground. Let us know more about earth wire. Earth wire is connected to a metal plate buried deep underground, as you can see in the picture. A deep pit is dug into the ground and a galvanized iron plate is placed inside along with charcoal and sand for the purpose of maintaining low resistance around the plate. Earth wire is there to protect you if there should be a break or defect in the wire, so the current will go to the ground instead of through you. Let us know more about fuse wire. The live wire and the neutral wire are connected to the electric meter through a fuse. Fuse wire is used to protect domestic electrical appliances. It is made up of a mixture of substances and having a specific melting point. It is connected in series to the electric appliances. This fuse wire is fitted in a groove in a body of porcelain like non-conducting material, as you can see in the diagram. For domestic use, fuse wires with upper limits of 1 ampere, 2 ampere, 3 ampere, 4 ampere, 5 ampere and 10 ampere are used. An electric fuse is used as a safety device for the protection of electric circuits and appliances due to short circuiting or overloading of the electric circuits. When a high current flows through the electric circuit due to short circuit or overloading, the fuse wire heats up and melts, as you can see here in the picture. And in this way, the circuit gets broken and the current stops flowing, thereby saving the electric circuits and appliances from any damages. Electricity is of utmost importance in the modern world. We depend on it for almost everything in our day-to-day life. Therefore, we have to use the electricity wisely and safely so that it may not damage our life and the properties. So, here are some precautions to be taken while using the electricity. As you can see here in the picture, the electric switches and the sockets should be fitted at a certain height at which children cannot reach because they have a lot of curiosity about all these plugs and wires. So they may put fingers, pins, or some other things in the open sockets and it may hurt them. As you can see in the second picture, plug wires should not be pulled while removing a plug from its socket. While doing so, the entire socket may come along with the wire and it may lead to a severe accident. Before cleaning or repairing an electrical appliances, it should be switched off and its plug should be removed from the socket. Also, don't plug a bunch of stuff into one outlet. If so many devices are connected to a same circuit at a time, it may cause overloading and it may damage the circuit also. Some more precautions we need to take while using electricity are here. One's hands should be dry while handling an electrical appliances and as far as possible one should use footwear with rubber soles. As rubber is an insulator, it prevents the current from flowing through our body, thereby protecting it. If a person gets an electric shock, you should not touch that person. You should switch off the main switch and if the switch is too far or you do not know where it located, then you should remove the plug from the socket if possible. If not, then you should use a wooden pole to push the person away from the electric wire. Mostly, parallel connection is preferred over series connection. Why? Let us see. As you can see here in the picture, 5 bulbs are connected in series connection. When any one of them does not function because of some reason or any damage to the wire, the circuit gets break and there is no flow of electricity. As a result, there will not be current flow through the wire and all the 5 bulbs which are connected in series with that bulb gets off. Now let us see what happens in parallel connection. Here you can see the 5 bulbs are connected in parallel connection. Even if any one of the several bulbs connected in parallel becomes non-functional because of some damage to its filament or damage to the wire, the circuit does not break as the current flows through the other path and the rest of the bulbs in connection lights up. Mostly, parallel connection is preferred over series connection. You can see here in the picture, one bulb is connected in series. In second picture, you can see two bulbs are connected in series. They will give less light than if they had been connected individually. If three bulbs are connected in series, their light output will decrease further. Therefore, increasing the number of bulbs in a series circuit decreases the brightness of the bulb. Now, when several bulbs are connected in parallel, they emit the same amount of light as when they are connected individually in the circuit. So here you can see the brightness of the bulb, all the bulb is same.